Hi friends, in this video we'll see how a capacitor reacts when it is subjected to alternating voltage. Consider a simple circuit. Here you have external alternating voltage and here you have capacitor, and assume that this circuit doesn't have normal resistance. It is purely capacitive. Okay, what happens here? As the current flows for some short time, then first the capacitor gets charged and charges get accumulated, and so say if for some time current passes in this direction, charges get accumulated, right? And as the charges get accumulated, the potential difference across these plates increases slowly, and that will try to oppose the current. So this nature of this capacitor, it acts something like a resistance. When capacitor gets fully charged, the current in circuit falls to zero. But then what happens? The EMF also changes its direction, right? The other part of cycle. Then the current direction reverses and the capacitor also gets charged. First it gets discharged and then it gets charged in the opposite direction. And this is the typical cycle. Let's go into the details. We know that the potential difference across these two plates of capacitor is nothing but charge divided by the capacitance, right? And by Kirchhoff's loop rule, what can I say? The external voltage, which is Vm sine omega t, say, it is given by this Q by C, which is nothing but the potential difference across the capacitor plates. Everything is fine till now, but I want to know the current. So I don't know what is charge, but I know that current can be written as dq by dt. So from this, what can I write? Current is nothing but d by dt of charge. Charge. What is charge? C into Vm into sine omega t from this equation. Now C and Vm are constants, so I can write current as Vm into C into cos omega t, and I have omega here. So this is my current, right? I'll write the same equation in this form. Vm by 1 by omega c. Why am I writing in this form? Because here this one 1 by omega c, this is acting as resistance and this is known as capacitive reactance, just like we had inductive reactance in the previous video. The units are ohm here also, and Im, I can write Vm by 1 by omega c as Im, that is the current amplitude. So my current, instantaneous current, will be Im into cos omega t. Hope everything is fine till now. But by some trigonometric identity, I can write cos omega t as sin omega t plus pi by 2. So my final equation will be Im sin omega t plus pi by 2. This is my current. Let me write it again. Im sin omega t plus pi by 2. And the voltage is given by Vm sin omega t, right? What can you observe from these two equations? Here you have omega t and here you have omega t plus pi by 2. So current is pi by 2 ahead of voltage. Are you getting me? Current reaches its maximum value first and later voltage reaches its maximum value. And after what amount of time? Which is equal to pi by 2 angle, that is nothing but t by 4. After 1/4 of a cycle, so current reaches its maximum value earlier than voltage by t by 4, that is 1/4 of a time period. See this problem. If I have a capacitor connected with a bulb, say electric bulb, and again I have a voltage source here, AC voltage source. Now if I decrease the capacitance, what will happen? Will the brightness of this bulb increase or decrease? Note that the capacitive reactance is given by 1 by omega c. Here it is what? Inversely proportional to omega and inversely proportional to capacitance as well. So if capacitance decreases, my reactance is going to increase. And reactance is something like resistance, right? So if more the reactance, less will be the current. Or in other terms, of this external voltage, you have to give a larger share of voltage to this capacitor if capacitance decreases. That is, if inductance increase, if reactance increases. I'm sorry. So finally, if my capacitance decreases, my bulb or the brightness of my bulb is going to decrease. Hope this is clear. Now let us see the phasor diagram for this circuit. This will be the voltage as usual say, and the perpendicular component will be Vm sine omega t. That is the instantaneous voltage. Now the current is ahead of voltage, right? And it is ahead by pi by 2. So the current phasor will be like this, where this is pi by 2. This will be Im in magnitude, and the perpendicular component of this one, this part, it will give you the instantaneous current Im sine omega t plus pi by 2. Okay. Now, if this is the voltage which varies sinusoidally, then I have to draw the current also, right? How does it vary? It varies in this way, something like this. Okay. So the maximum value of current is somewhere here, and maximum value of voltage is here. Which comes first? Current takes its maximum value first, and then voltage takes. And the time period between these two events is t by 4, 1 by 4th of a time period, and this is omega t. Okay. Hope everything is fine till now. What about power? Power in capacitive circuit is given by IV only, but the instantaneous current here is Im sine omega t plus pi by 2, right? And voltage as usual is Vm sine omega t. Okay, I can write these two terms as Im Vm sine omega t and cos omega t, because sine omega t plus pi by 2 is nothing but cos omega t, right? And so I have Im Vm by 2 and sine 2 omega t here. Hope this is clear. This is the power, right? So if I want to find the average power, what I'll do, I'll take the average here, average of this whole term. Since Im Vm are constants, I only have to take the average of sine 2 omega t. And interestingly, the sine 2 omega t varies from -1 to 1, right? Because that is sine. So the average of it will be 0. So the average power in this circuit is also 0, just like we had in inductive circuit. And this is mathematically okay, but how to explain you? Actually, what happens there is, say you have a capacitor and current was varying with omega t in this way, right? Or something like this. So what happens here is, for this part, current is positive, right? So there the capacitor was getting charged. Say plate A gets positive charges and plate B gets negative charges. So the capacitor was getting charged there, and hence there is some work need to be done. Okay, let it be something. And what happens here for this part of cycle? The current is negative. So the capacitor is getting discharged. Are you getting me? So the work absorbed here will be equal to the work given out here, and hence it is neutralized, nullified. And what happens in this part of cycle, third part of cycle, the capacitor gets charged again, but the current is negative still. So this time what happens, plate B gets the positive charges and plate A gets the negative charges for this part, for the third part of cycle. And similarly it gets discharged again in the fourth part of cycle and the effect is nullified again. So the average power is 0 over a complete cycle. You understood me? And that'll do it. This is the end of this video, and the next video will probably be the most important one in this entire chapter. In that I'm going to discuss how all the three elements react when applied to a external voltage source, AC voltage source. That is, we are going to discuss LCR circuit. That is very important. So keep watching and bye.